To build children as problem solvers, we want them to have as wide an experience as problem solving as possible. Now, a barrier to that could be coverage, or the idea that today is mainly a fluency lesson. How can we build problem solving in today's content when we've the pressures of coverage? So what I wanted to have a look at in routines of mathematical exploration is how we can build in problem solving question structures into day-to-day lessons. So a common structure is any question where there are different possible answers. Or even we could say, well, how many answers are there? So here are questions that look at calculations involving subtractions involving single digit numbers. And here, for question A, the child finds all the answers and then works systematically for question B to find all the answers. And then the further challenge, having found all those different answers and developing fluency, if you like, is being able to explain why question B has fewer answers than question A. And the child says it's because there's not as many numbers you can start from. Now, similarly, this is a how many ways question. Make all the fractions that are more than 0.5 and less than 0.75 using these numbers. So that might be inserted where we are essentially practicing helping the children to become fluent. But the question structure enables the problem solving, in this case, children thinking systematically, to find all the different possible answers. So how many ways is absolutely ideal for that. Another tool that could often be used, even particularly working at depth, is it if we were looking at rounding, rounded to the nearest 10, my number is 90. And then I could layer in a second skill for children to have to practice that alongside. So my number is a multiple of 7. What is my number? And children could have a go at the second example. Found all the possible answers. And then maybe they could end up designing their own question. So we're ending up practicing those same skills that would be embedded in a lesson. But we've got this opportunity for depth and creation as well, to really developing children's reasoning and problem solving. Now, of course, there's what I'd call domain-specific examples of problem solving as well. So if we were looking at data handling and we were interpreting graphs, and we think, well, what does problem solving, what does depth in thinking look like in this context? Now, hopefully my resources are really helpful for that. And you can just look, well, this is a domain-specific tool. In this case, matching the headings to the graph. So if I just talk about one example, the height of a child ages 0 to 9 would be the top right graph because we have this gradual increase. Of course, our height doesn't fluctuate in any way. And in this instance, the depth of thinking coming from matching the headings to the graphs. So lots of different tools that are domain specific. So whilst today might be a fluency lesson, having those tools that make sure that problem solving can be embedded on a daily basis, so powerful.